Today we're going to talk about some different types of what are called variation functions. So some of these you may be familiar with, others you may not be. I assume most of the vocab will at least be new. It's kind of a shorter lesson today, and then we'll get you started on the homework. So the four types of functions we're going to talk about are direct variation, indirect variation, or inverse variation, joint variation, and combined variation. So let's start with direct variation. So the definition, textbook definition, would be that y varies directly as x if there is some non-zero constant k, so that y equals k times x. K is called the constant of variation, or the variation constant. What this really means is that for a direct variation function, you have two variables, and one of them is multiplied by some number. So y equals something times x. What that something is can be anything, but you know that you're probably going to get some linear function, and that the two are going to be very directly related. As one goes up, so does the other one. As x gets bigger, so does y in this case. The next is called, that we're going to talk about, is called joint variation, and that's when one quantity varies directly as the product of two or more other quantities. So we're going to have multiple variables, three variables in this case. One of the variables is equal to the product of the other two variables times some constant. So you can see how it's very similar to the direct variation. This was k times x. This one's k times xz. So there's two variables. You multiply them together, then you multiply by your variation constant, and you end up with your joint variation function. So for example, if y equals 5xz, so y equals 5xz, x is 6 and z is -2. So y is 5. That 5 is our variation constant. 5 is our k. If x is 6 and z is -2, then we could find y, right? It's going to be 5 times 6 is 30 times -2. Y is going to have to be the -60. That's a terrible 60. Okay, so joint variation and direct variation, very, very similar. Joint variation, you're just going to have more than one variable involved in that relationship. Moving on to the third type, inverse variation. So this is y varies inversely as x. So we used to call it directly. Right now it's inversely, so it's the inverse. So instead of multiplying k by x, we're going to divide k by x. So this is obviously a rational expression. So when you see something like this, you know it's going to be an inverse variation involved. So when you have a variable in the denominator, this is what we end up with. So y equals 4 divided by x, for example, or -7 divided by x, whatever it may be. Instead of multiplying the constant by the variable, we're going to divide the constant by the variable. And this is inverse variation. So direct variation, y equals k times x. Joint variation, y equals k times x times z, or w, or whatever. And then inverse variation, y equals k over x. And then the last one is combined variation, and it's exactly what you think it is. We're combining different types of variation. So this is one example of combined variation because we have multiple variables involved, right? Y, x, and z. We'll talk about what those ones are here in a second. But the idea is you've got one variable is the direct variation. It varies directly with x, right? Because here's a direct variation. But it also varies indirectly with z. So we've got two different variables and two different types of variation happening. K is still just a constant. The reason we're going to have two of these expressions, two of these equations, notice these are exactly the same, but this one has ones and this one has twos. In order to solve for missing pieces, we're going to have a set of data for one of them and then solve for the other. So we're going to set up two equations just so we can work through it. It can also be solved for k, and if we solve them both for k, then you can set those two expressions equal to each other. And get k out of it if that's something that's helpful. But let's look at an example of some computation you might do in the homework, and then you'll kind of see why we have two of those. So suppose f varies directly as g, inversely as h. So what that means is I have f varies directly as g, so it's going to be k times g, and inversely as h, which means I have to divide by h, which is exactly what we have over here. We just have two of them, like I talked about, one with ones, one with twos. You don't have to write it that way. The book always will, but you can do it without if you just kind of follow along with what I'm going to do. It says to find g, g is what we're looking for, when f is 18 and h is -3. So if I try that and I plug those in, 18 is equal to k times g, because that's what I'm looking for, over -3. The problem is I have two variables, right? I don't know what k is and I don't know what g is. I can't solve that. However, what they have to do is give you one set of data. So it's saying if g is 24 when h is 2 and f is 6. So I can kind of take a time out and plug that stuff in. So if f is 6, I still don't know what k is, but it's saying that g will be 24 and h will be 2. Now this I can solve because there's only one variable. So let's do that. 24 over 2 is 12, so 6 is equal to 12k. Divide both sides by 12, and we will see that k is 1/2, right, or 0.5. So now if I take this and plug it into that guy for k, then I will be able to solve for g. So let's go 18 is equal to 1/2 for k. G I still don't know, that's the whole point, over -3. I'm going to start by multiplying by -3. So -3 times 18 is -54 equals 1/2 of g. So if I multiply both sides by 2, I can get rid of the 1/2. So 2 times 54 is -108 is equal to g. Okay, so that's why they write two different functions. One of these will be for the values they give you, and the other one would be for the one you're going to solve. I just like to run through it separately, but that's how they're going to do it. Okay, that's it. We've got 4 types of variation. Let's write those down again real quick. We have direct, where one variable varies directly with the other one. We should make that a... So y equals something times x. We have joint, which is just like direct, but we have multiple variables involved. So y equals k times x times, they used z, let's call it w this time, it doesn't matter. Where these two are variables, k is always the constant. Then we have inverse variation, where y is equal to k divided by a variable. And finally, combined, where we're going to combine direct and indirect, or direct and inverse. Y is equal to k times one variable divided by another variable. Okay, so those are your 4 types of variation equations, variation functions. Homework's going to have you do some calculations with all of them. If you have any questions, as always, reach out. Otherwise, have a great day and good luck.